Well, students, this is question from November 22, variant 43, question number 3. A ring of mass 4 kg is threaded on a smooth circular rigid wire with center C. The wire is fixed in a vertical plane and the ring is kept at rest by a light string connected to A, the highest point of the circle. The string makes an angle 25 degrees to the vertical. Find the tension in the string and the magnitude of the normal reaction of the wire on the ring. So, relative to the ring, the weight of the ring is 40 newtons. Relative to the ring, tension is here in the wire. This ring is actually touching this big circular uh, wire at this point, and the reaction would be at this particular point. As it's touching the circular wire from outside, so first you draw the tangent, and the normal reaction is here. This is the normal reaction, say Rn newtons. The normal reaction is Rn newtons. So Rn is question mark, tension in the string is question mark. So on the ring, which is a 4 kg, there are 3 forces acting on it: T newtons, R newtons, and 40 newtons. But angle is not mentioned there in between the forces. So using the property, so now working with the angles, the property of the circle, the line which is perpendicular to the tangent passes through the center. So this line is passing through the center, and further, what I can do, because my intention is to resolve the force into components horizontally and vertically, so it's better to draw a horizontal dotted line and the vertical dotted line. So resolving forces x-axis or y-axis or horizontally and vertically, but angle is not there. So for the angle, carefully do the working. You can join this C point to this dotted line. So we have a triangle. Right angle triangle. One angle is 65. So this angle would be, one angle is 25. So 90 minus 25. This angle is 90. So this is 65. And further, this angle is 25 degrees because of the isosceles triangle. So this angle is 25 degree. As a result, this angle is coming as 40. If this angle is 40, this angle must be 40. Vertically opposite angles. Vertically opposite angles. So horizontal and this line, because we extended this line towards C, so vertically opposite angles. Now, after this basic working with the angles, and after knowing the angle here, what I can do, I can resolve the forces horizontally and vertically. So I have marked the tension of the string as Tn. So horizontally and vertically, rightwards and upward. So this is T cos of relative to this 25 or relative to this 60, 65. So any angle you can use for resolving. So let us use this 65. So this must be T cos of 65, and this force is T, this component is T sine of 65, because this force was T, and for your understanding, I can write separately. 65 is here, so this must be T cos of 65, T sine of 65. T cos of 65 and T sine of 65, you can also write the components relative to the angle 25. Also, leftwards and downwards. So this is R cos of 40 R sine of 40. And 40 Newton is already vertical. So writing resolving forces horizontally and vertically. So 40 is okay. So we have resolved T into the two components, T cos of 45 and T sine of 45, and R Newton with the normal reaction, R cos of 40 and R sine of 40. Now, using the equilibrium, as the ring is in equilibrium, so rightward forces equals to leftward forces and upward forces equals to the downward forces. So first write upward. How many forces are there, or can you identify the forces which are acting in the up direction? Yes, T sine of 65 is one force which is vertically up. So T sine of 65 above, T sine of 65 degrees, and downwards are 40 plus, I'm sorry, here is R. Equals to R sine of 40, number one. And the second, horizontally, rightward force is T cos of 65. T cos of 65 degrees is equal to R cos of 40. Leftward equals to rightward. So R cos of 40 is equals to T cos of 65, and upward the only force is T sine of 65, two forces in the downward direction, 40 plus R sine of 40. So solving them simultaneously, you can find the value of R and the value of T. So solving equations simultaneously, so you'll find the value of R is equals to 40 and the value of T is equals to 72.5. So these are the two answers, and the T I'm writing correct to three significant periods. This is one approach for solving this question. And yes, we have the answers. So you can make two equations and solving them simultaneously. You can find the value of the unknowns R and T. You can also solve this question by using a different technique, and that is the Lamè's theorem. Because there are three forces acting. There are three forces acting on the ring, which is a 4 kg, T newtons and R newtons and 40 newtons. So what you can do, so the alternate method. Weight is vertically downwards, 40 newtons. Tension is here, T newtons. One force was acting here, which is R newtons. Now, let us check. What is the angle between T and 40? I mean to say this angle T and 40. So this is basically 90 degree, 90 plus 65. So this angle is 90 plus 65. This angle is 90 plus 65 means 155 degrees this angle. And next, the angle between R and 40. Yes, if we have 40 newtons, if we have this angle as 40 degrees, this is 50 degrees. So angle between R Newton force and 40 Newton force is 50. So you can write 50 here. So if 155 and 50, add these two and subtract from 360, this is 155. 155 plus 155 plus 50 is 360. In this way, we have the angles, and there are three forces. Ring is here. So you can apply Lamè's theorem. So it's very simple. So with the help, so angle we find in both the cases, but for the three cases, as there are three forces in equilibrium, as there are three forces in equilibrium, you can apply the Lami's theorem. Lami's theorem is, so use R over sine of the angle between the other two forces. If R, the other two forces are T and 40, the angle between T and 40 is 155. R over sine of the angle between the other two forces is equals to 40 over sine of the angle between other two forces, which is other two forces is T and R. So again, 155 degrees. So clearly 155 sine 155 cancels, and we have R straight away just in one line you can get this answer. So R newtons is the tension of the string, and with T over sine of the angle between the other two forces 50 is equals to 40 over sine of the angle between the other two forces and 55. So T, when you calculate 40 over sine of 155 multiplied by sine is equal to 72.5 newtons. So you can also find the answer by using the Lami's theorem, because there are three forces acting on the ring R, and the ring is in equilibrium. So in this way, you can solve this question. So the main activity was with the angles. So if you're confident with the angles, how to shift the angle from one side to the other, so you can easily manage the situation either by using the components or method or by using Lami's theorem. Thank you.